in case you don't know, for in case of all you, some of you don't know, actually, if you do jet impulse, theoretically every pulse is being tested, right? If you don't understand what I mean, then you need to go and rethink how you learn, what is the concept of designing a pulse. Hey, please don't draw on my screen. Somebody is drawing on my screen. Okay, so evaluation based on soil test, which is a static methods, which today we are covering. Another method is by the pulse dynamics, pulse driving dynamics by the cat web, pulse driving formula, like highly formula, okay, that kind of stuff. So we will focus on static methods. Okay, static methods, of course, on your left, you see analysis based on soil properties. You use your alpha, beta, gamma method. All this is you're supposed to have what you learn in your undergraduate, in your year 2, if I'm not wrong. Okay. Then second part is the Insitu Test, whether you use SPT or correlation with to our CBT so that you can correlate to the end bearing or skin friction. Just another announcement for those who come in under Norena, please go on your video and click on your face and change your name. Okay. Okay. Next. Now, just a quick recap for those what you learn in school. Actually, these things are all taken from the slides. From all my undergraduate or postgraduate slides. But for information, I graduated from Master Geotech in NUS. So Prof Lee is also my professor for my project. So this is what you learn. I just go through very quickly. For clay, for end bearing, usually we use 9CU. For total stress approach, we will use the wait, there is a chat. There's somebody. I cannot see the chat.
It's okay, Kiawi, it's okay. I just sent a chat to everyone to tell them.
Okay. So for the stress is the total stress, you can use the alpha method. Now you also can use the effective method for the cohesive soil. You can use the beta method, okay, which you will need the OCR and friction angle, that kind of stuff, you know. Now, this one, give away marks one. How do you obtain OCR? This one must ask the undergraduate student. How do I see the list of people? Let me see. I must see the list of people.
From the chat room.
Yeah, I know. I can see now. Okay, let me ask. I don't know who is undergraduate student. Okay, I ask Nini. Nini, are you an undergraduate student?
No, I joined the GC and will be joining master coming August.
Oh, so you just graduated, is it?
Yeah.
Oh, that's good. So those how do you do that? How do you obtain OCR?
Actually, science is for me first time.
Sorry? No, it's okay. You say if you don't know, it's okay. Let's move on. Don't waste time. Do you know how to obtain OCR?
OCR over consolidated swine ratio clear,
yeah,
right?
Yeah, correct. So how do you obtain OCR? How do you get this number?
Obtained by, sorry.
Obtained by what, sorry?
It's depend on the stress or the swine.
Yeah, I know, depending on the stress state of the soil. I'm asking you, how do you get this number?
Actually, I don't know.
Okay, you don't know, right? Okay, so Prof, you've got some work to do, Prof. Okay. For now, I'm telling you what is LTA CDC requirement. LTA CDC means civil design criteria. Okay, if you are doing LTA job, in my whole majority part of my career, I do LTA projects. Okay, so for most of you, you probably will also handle LTA projects. Now, LTA CDC requirement require you to use both total stress and effective stress and use the most onerous for the design. Okay, I am telling you, is there any people from LTA before I continue? Anybody from LTA? Hey, If you from LTA, can you just
Yes, Kelvin.
yes, who is from LTA?
That is like Kelvin.
Philip ah.
No, Dennis.
Dennis.
Daniel ah.
Dennis.
Dennis, okay, Dennis. Dennis, do you know that, Dennis? Do you know that actually your CDC requirement to check both cases?
Yeah, but I'm not very familiar with CDC lah.
You are the project engineer side, is it? You're the project side, is it?
Yeah, correct.
Okay, good. Now you know. Now you know how to check on your GTT department, okay? Yeah. I guarantee your GTT department, many people still don't know, yeah. Okay, move on.
All right.
Now, cohesionless sand, we can sorry, means sand. Okay, so it's a factor of also a bearing capacity factor for sand. You can check the figure. So there's a some number recommended. So ball pulse is 2 to 11. Okay, for shaft friction for sand is also have depending on the friction angle and also the effective stress. Okay, this is what you learn in school. Actually, this slide is from the Master Geotech slide, so I just show you quickly. But you see this number, you must ask yourself. So this is the next question I want to ask you. Why the bearing capacity factor for ball pulse varies a lot from 2 to 11? You notice the ball pulse from 2 to 11 megapascal, right? Why? Wow, this is my favorite question. I must ask something. Any P here? Anyone is a P here?
Maybe no. It's probably the lecturer.
No, I don't want to ask the lecturer. I just no. No P. Interesting. Last time Master Geotech many P, you know. Okay, then I choose one. Okay, Jing Ying.
Hello.
Yes, Jing Ying. Are you undergraduate or master student or PhD?
Just started masters.
Just master. Okay, never mind. You tell me why is it varies a lot according to what you think, what you know.
I made a guess. Does it depend on the method of testing?
Method of?
Testing.
No.
Oops, okay. I don't know the answer.
It's okay. Okay, I must ask PhD student. I know there are some people. Who is PhD student? Prof, who is your PhD student? Who is the PhD student?
Let me see. I don't know, man.
Hey, you don't need for me to pinpoint. If you are a PhD student, you can volunteer yourself to answer.
All right, I'll volunteer myself.
You are? Sorry?
Joel.
Joel, is it? Joel, okay, good. Joel, have you been working or you have been studying all the way to PhD?
Working and studying.
Working is good. So what do you think it varies a lot?
It's the method of installation. It can be loose material at the bottom of the base. So that's why there's a varying stress.
Yeah, correct. So that's why PhD student is PhD student. Okay. Later you will know. Actually, in sand, we have a problem. Actually, ball pulse is a lot of them time depend on the workmanship. Okay. So why they say varies from 2 to 11? Because they take so many MP case study. They notice how come some M very, very slow, some M very, very large. So really depends on the workmanship. And especially in sand, because once you excavate the soil in sand, the overburden is relieved, you will tend to have some disturbance, okay, has to do at the bottom, okay, especially when we have in the country whereby the groundwater level is so high, right? So it's natural that this is this end bearing is very difficult to control. Now, remember this question and remember the first question I asked, which one is the most common case in Singapore? The load transfer. Friction only, friction and end bearing or pure end bearing. Okay, you just remember, you just remember. Now, in actual fact, you should know, most soil don't behave like pure clay or pure sand. For those people, for those students, you have not seen a proper SI report. This is what probably like a SI report extract from an SI report. You will see they write a lot of description, on the consistency, the color, and the material. and the formation, what kind of formation is that, right? You have say like this is a slightly sandy silt. Okay, then you have the fine grained sandy silt. Okay, so you won't have the pure sand and pure clay. Okay, and then you see the whole ball here about a stretch of 13 meters. They only do one lab test, and most projects it's not a research project, so everybody is looking at money only. So they will not have a lot of laboratory tests for you to test whether this is really what kind of soil, you know, whether it's a predominant a clay or what sort. So that is a real fact that you're looking at. That's why this called practical geotechnical guide, right? It's not according to I want to check, I want to test every sample. You do not have the luxury in the actual case. Okay. Now, are there other reasons besides cost concern? Are there other reasons that why we do not have this lab test? Any reason? Let me see some people. Ask some people. Oh, ask okay. Ask the. Who should I ask? Let me ask. Okay, Rajan, are you here?
Yes.
Rajan, you are. When I pick you, can you introduce your PhD, master, or undergrad?
No, I graduated. I'm working now.
You're working already, is it?
Yeah.
Okay,
Because
so
I think the other reason is the time.
the time, is it?
Yeah.
Okay, so time also money, right? So to reduce the time, right?
Yes.
So we do lesser lab tests, right?
Yes.
Okay. I don't want. There's no definite answer, so y'all don't need to worry that whether your answer is wrong. It's just a sharing session. Okay, I do not say I'm the expert or whatever I say you have to follow, but I just want y'all to think when you are faced with this kind of situation, how will you react and how will you actually do your work properly, to carry out your work properly. Okay, so I will not give you the answer. You think through why a lot of time you cannot get. Later I will come back to this question. Okay, later I'll come back to this question. Now, this is why we actually rely more on Insitu Test, because we do not have so many lab tests, right? In order for you to do your alpha method, for example, you need to have many UU tests. Okay, you have to have many UU tests. You need to have many samples. Okay, now, so that's the reason why we use Insitu Test like SPT, which is very easily conducted and very cheap and very fast. Okay, so I believe everyone should know what is SPT. So I don't want to go. The full name is called Standard Penetration Resistance. Standard Penetration Test. Okay, so in CU we usually use 5N. Okay, we use 5N, or maybe some of them use to 6N. Okay, then for sand, actually there's a chart you can use to determine the friction angle. Now, and in local data, our friction is between 2 to 3N. If you look at all the paper, whether it's old alluvium, whether it's Bukit Formation, Jurong Formation, most of us, in fact, all of Singapore I see, nobody use 4N. Okay, maximum, I use maximum up to 3.5N. That's the maximum I use. That's after the test, after the pilot test, I revise the design. That's all. So we don't usually go to that higher zone, but in actual fact, I believe it can mobilize higher, but that's one thing. But now, another question time. Why do you think the friction angle is between 2 to 3 based on local data? Let me see who should answer this question. I think this one must be PhD student. Come, PhD student. Any PhD student can answer. Any PhD student want to answer? Hey, I think here got P, ma. I think I see something. I think he's P, you know. Any PhD or P want to answer? Oh, never mind. I ask who is the consultant here? Who work in the consultant office? Okay, you don't want to answer. I ask you. Zhu Lian, are you here?
Yes, I'm here. But I just finished my NS, so I don't know about this question.
Okay, never mind. I want to ask this guy, Guo Xianghuat. Hello? Hey, Mr. Guo, do I know you? Your name sound very familiar to me.
Prof Go.
Sorry?
The one is a Prof Go, right? Prof Go Xianghua.
Is it Prof? Is it Prof
Yeah.
Go?
Yeah, Prof Go.
Oh, okay. Sorry. Okay, maybe Prof can reply this question also. Why is it between 2 to 3 N? Yeah, Prof Go, can you answer? Or you give us your not don't say answer. Can you give us your thoughts? Why is it between 2 to 3 N? If nobody answer, then I don't answer. I skip first, okay? Now, what about M bearing? You see, we don't talk about M bearing. We seldom say hey, the M bearing is between what we seldom talk, okay? But you just take note of these two questions first. Now, okay, so the common alpha method. If you base on the Terzaghi and Pax diagram, you notice that okay, we usually talk about we don't stop the ball power when we do ball powers. We don't design what stop the ball power in SPT 10, 20, or even 30. Minimum we go is 50. Okay, usually we use 100. So when you're in the SPT 50 to 100 zone, usually the CU is already very high, at least 300 and above. So usually the alpha is about 0.35. Okay, if you substitute 0.35 into this 5 to 6N, you will get probably 1.75 to 2.1N, which is why we always say that we like to use, how do I say, we use Insitu Test to correlate and get the fiction, okay? Now, for M bearing, just now I said, right? Remember M bearing, nice CU, right? If your nice CU is about 45 to 54 N, okay? And this N, usually we are talking about in the SPT of 50 or 100. But we usually don't use up to 100. I mean, we set the limiting M bearing. So this one later on in one of the practical example, probably we will talk about this thing.